Multiply 7 by 1 by 0.4 by the chance that chemistry becomes biology, by the chance that biology awakens into thought, by the chance that thought learns to send a signal screaming into the dark. Even with the coldest, most ruthless math, this galaxy should be teeming with intelligence. So we pointed every telescope, every dish, every detector we had at the sky, and the universe answered with nothing. Not a whisper, not a hum, not one single voice. The math says the cosmos should be a symphony. Instead, we're sitting alone in an empty concert hall, wondering if every orchestra that ever played was silenced before the first note reached our ears.
In 1961, astronomer Frank Drake formalized the Fermi paradox into an equation, an attempt to calculate exactly how many detectable civilizations should exist in our galaxy. It looks like this. N equals R star times FP times NE times FL times FI times FC times L. Each variable represents a step in the emergence of detectable intelligence. R star equals rate of star formation in our galaxy, approximately 7 stars per year. FP equals fraction of stars with planets, approximately 1. Nearly all stars have planets. NE equals average number of habitable planets per star system, approximately 0.4. FL equals fraction of habitable planets that develop life, question mark. Fi equals fraction of life-bearing planets that develop intelligence, question mark. FC equals fraction that develop detectable technology, question mark. L equals length of time civilizations remain detectable, question mark. The first 3 variables, we know them now. Kepler, TESS, and other telescopes have given us real data. The last 4, complete unknowns. But let's plug in conservative estimates. FL equals 0.1. 10% of habitable planets develop life. Fi equals 0.1. 10% of life becomes intelligent. FC equals 0.1. 10% become technological. L equals 10,000 years. How long civilizations broadcast? Calculate. N equals 7 times 1 times 0.4 times 0.1 times 0.1 times 0.1 times 10,000. N equals 28. 28 detectable civilizations in our galaxy right now. But we can adjust those unknowns, make them more optimistic. What if life emerges on 50% of habitable planets? What if technological civilizations last 1,000,000 years? Suddenly, N jumps into the thousands. Even with pessimistic assumptions, the answer should never be 0. And yet, when we point our radio telescopes at the sky, when we analyze millions of star systems for signs of megastructures, when we search for technosignatures, waste heat, atmospheric pollution, we find nothing. The equation predicts abundance. Reality delivers silence. Something is wrong. Either our understanding of probability is broken, or something is filtering civilizations out of existence. In a dark forest universe, the optimal strategy is detect, analyze, eliminate. No communication, no warning, no mercy. Just a relativistic kill vehicle traveling at 90% light speed fired from across the galaxy. By the time you see it coming, you have seconds to live. This would explain the silence perfectly. Every civilization learns this rule. Every civilization goes dark. They stop broadcasting. They hide their emissions. They watch and listen, but they never speak. Because speaking reveals your coordinates, and revealing your coordinates is suicide. Now think about what humanity has done. We've been broadcasting radio signals for over 100 years. Those signals have reached thousands of star systems by now. We sent the Voyager Golden Record with a literal map to Earth. We beamed the Arecibo message towards star cluster M13.
We announced our existence to the cosmos. If the dark forest is real, we just painted a target on our entire species. Let's talk about something most videos ignore: the speed of colonization. Even with slower-than-light travel, a civilization could colonize the entire galaxy in a cosmically short time frame. Here's the math. Assume a civilization develops self-replicating probes, von Neumann machines. These probes travel at 10% the speed of light, slow by sci-fi standards, but achievable with near-future technology. Each probe reaches a new star system, builds copies of itself using local resources, then those copies continue outward. At 10% light speed, crossing the galaxy would take about 1 million years. Add time for replication and construction at each stop, let's say 1,000 years per system. Even with this delay, full galactic colonization would take roughly 10 million years. 10 million years, that's nothing in cosmic terms. The galaxy is 13.6 billion years old. Earth is 4.5 billion years old. Intelligent life has had billions of years to arise, develop technology, and spread. A civilization that started just 10 million years ago would have colonized the entire galaxy by now. Yet we see no evidence of this anywhere. No member structures, no Dyson swarms, no engineered star systems, no probes visiting our solar system. Nothing. This is sometimes called the WOW signal in reverse. In 1977, we detected a radio signal so unusual that the astronomer wrote "WOW" on the printout. It came from the direction of Sagittarius. It lasted 72 seconds. It never repeated. For decades, people speculated it was alien. It probably wasn't. Most likely a comet or natural phenomenon. But here's the thing. That was one ambiguous signal in 50 years of searching. If the galaxy were full of civilizations, we shouldn't be finding one weird signal. We should be drowning in them. Every frequency should be saturated. Every star system should show signs of engineering. The night sky should be loud. Instead, it's silent. Perfectly, impossibly silent. Let's return to pure mathematics for a moment, because there's something deeply wrong with the probability calculations. The Drak equation assumes independence, that each variable is separate. But what if they're not? What if f of L, f of I, and f of C are correlated? What if the conditions that allow life to emerge also make intelligence inevitable? Or what if intelligence makes self-destruction inevitable? Then the equation doesn't work. The variables aren't independent. Consider this alternative formulation. P of detection equals P of life times P of intelligence life times P of technology intelligence times P of survival technology times P of expansion survival. Each probability is conditional on the previous one. And here's the nightmare scenario. What if P of survival technology approaches 0? What if the development of advanced technology always leads to extinction? Not sometimes, not usually, always. Maybe there's a fundamental law we haven't discovered yet, a thermodynamic principle, an information theory constraint, something that says civilizations that can destroy themselves will, not through bad luck or poor choices, but because the mathematics of complexity, power, and intelligence inevitably leads to catastrophic instability. Like a chemical reaction that's stable until it reaches a critical temperature. Then it explodes, every time. If this is true, then we're not looking at a paradox. We're looking at a law, the law of technological self-termination, and we're hurtling toward it right now.